Hi, welcome to this lesson on number patterns, finite geometric series. In this lesson, we're going to be looking at question 2 on solving a finite geometric series problem. They want us to calculate this following series. 10 plus 5 plus 5 over 2 plus 5 over 4 plus all the way up to 5 over 256. Okay, so first of all, let's verify if this is a geometric sequence, so it must be of the form a times r to the power n minus 1, where n is a natural number. Well, I see from get to 10 to 5, I multiply by a half. From 5 to 5 over 2, again, I'll multiply by a half. To get to 5 over 4, I'll multiply by a half again. So here, my first term a is 10, and my common ratio r is a half. Okay, so let's see if we can first find how many terms are in the series. Okay, because we know this is the last term, because we're going to need that when we use our sum formula. So recall the Sn formula. Because my r value is less than 1, by convention, I'm going to use the second formula, which is a into 1 minus r to the n over 1 minus r. How do I remember which is the first and second formula, besides the fact that I've been doing it for so long? Well, I just look at the r value and I immediately think if it's greater than 1, then r minus 1 is going to be positive. That's what I think. R minus 1 will be positive if r is greater than 1. So like if r is 10, then 10 minus 1 is 9, and that's positive. So I'm going to use r minus 1 in the numerator and denominator terms. R to the n minus 1 over r minus 1. That's when r is greater than 1. The moment I think of r less than 1, I think of the second formula. So like if r is, let's say, negative 3, then I know negative 3 is less than 1, and therefore when I say 1 minus r, it's going to be 1 minus minus 3, which will be 1 plus 3, which is 4. So I always look for that connection to know the formula that I'm going to use. So here, I'm going to need to know how many terms am I adding up n, what my first term a is, and what my common ratio r is. I know what my a value is, it's 10. I know what my r value is, it's a half. So we need to find out how many terms we're adding up in the sequence. Well, we know t sub n is going to be 10 times a half to the power n minus 1, where n is a natural number. And we want, when is this general term, at what position will the value be 5 over 256? Okay, so I'm going to solve here now for n. So I'm going to say half to the n minus 1 equals, so basically to get rid of that times 10, I divide by 10. So it becomes 10 there in the denominator. Let me use a calculator to try and simplify that. So it's going to be 5 over 10 times 256. And I get 1 over 512. Now I know my powers of 2 pretty well. So I know that this is going to be 2 to the power 9. But let's say you didn't know your powers of 2 very well. How do you solve this type of equation? The first way, the standard way, is to get the bases to match up. That's why I used powers of 2 there. Okay, so I did it the first way. It's going to be a half to the power n minus 1 equals 1 over 2 to the power 9. My exponent law says I can rewrite this entire expression as 1 over 2 raised to the power 9. So when I distribute the 1 here, 1 to the power 9 is just 1. And 2 to the power 9 is 2 to the power 9. So because the bases are the same, I can therefore match the exponents. N minus 1 equals 9. Therefore, adding 1 to both sides, I get n equals 10. But let's say you're in the position that either you didn't know how to match the bases of 2, or it was impossible to match the bases of 2. How do you go about solving now? A half to the power n minus 1 equals 1 over 512. Well, whenever we're solving any type of exponential equation where we don't know how to match the bases, we have to then use logarithms. So how do we do that? This is the base here with the exponent, a half. So therefore, to bring the exponent down, n minus 1, on both sides, I've taken the log of the base, which is a half, of the value on the right-hand side, which is 512. So let's see what that comes up to. N minus 1 equals. So on my calculator, I'm going to do, see the button here where it has log, it gives you the base and a value there. So the base I'm going to put as a half, and the number I'm going to put there is 1 over 512. And I get 9. N minus 1 equals 9. Therefore, adding 1 to both sides, n equals 10. So I get the exact same solution. Okay, so that's how you can do it either way. So now I'm looking for the sum of the first 10 terms. That's going to be 10 into 1 minus a half to the power 10 all over 1 minus a half. So I've just substituted a, n, and r there. And if I do that on my calculator, let's see what we get. A fraction, 10 into 1 minus, open brackets, a half to the power 10, close my brackets. See how I'm writing it very precisely on the calculator. 1 minus a half. And I get 5,115 all over 256. That is the final solution. All right. I'll see you in the next one.